Welcome back to video 6, everybody. So in this one, we're going to be completing the Lewis structure for the organic compound they gave us below. And we're going to answer these 4 questions that they have for us. So when we're completing these Lewis structures, there's basically 4 rules you need to abide by. You want to make sure that every single carbon gets 4 bonds, 0 lone pairs. Every single nitrogen gets 3 bonds and 1 lone pair. Every oxygen is going to get 2 bonds, 2 lone pairs. Every hydrogen gets 1 bond, 0 lone pairs. That's your holy Bible for the organic Lewis structures. Follow those rules all the time. You'll get a formal charge of 0, all right? So then once we finish this Lewis structure up, we go ahead and tack in all those double bonds, fill in all those lone pairs, make sure all the octets are satisfied. Then we can start looking at these questions. So first question they're asking us, how many carbon atoms are sp2 hybridized? So in order to be sp2 hybridized, that means our carbon needs to contain 3 electron groups surrounding it. So we're going to be looking for carbons that have 3 electron groups. That means either 3 atom-to-atom connections or 2 connections and a lone pair. In this case, we're just going to be looking for 3 atom-to-atom connections on these carbons. So when we start looking through this structure, we notice that all these carbons that have arrows pointing to them in red, all of these have 3 electron groups surrounding them. That's going to give us sp2 hybridization. So we're going to answer 4 for the number of sp2 hybridized carbons. When you're trying to determine the hybridization scheme of something, all you need to do is just look at your scheme, think of how many letters are being hybridized. So if it's sp2, that means there's 1 s and 2 p orbitals that are being hybridized. That's 3 orbitals in total. 1 plus 2 equals 3. That means we get those 3 electron groups for the sp2. 1 electron group, 2 electron group, 3 electron group. The number of electron groups equals the number of hybridized orbitals. That's all you got to do. For statement 2, they're asking us how many of the carbon-nitrogen bonds are formed from the overlap of an sp3 hybrid carbon with an sp3 hybrid nitrogen. So that means we need to identify a carbon and a nitrogen that are bound together that each have 4 electron groups. The only bond that we see that satisfies that criteria exists right here. This carbon is going to have 4 electron groups surrounding it. And this nitrogen is going to have 4 electron groups as well. So it's got 3 bonds and then 1 lone pair on this nitrogen. This carbon has 4 bonds. So they're both going to be sp3 hybridized. We've already talked about in lecture how the bonding works. What we're going to have happen here is that when these orbitals, or when this bond forms, the orbitals are going to overlap with one another. So then we just have the bond between carbon and nitrogen is the result of the sp3 hybrid from carbon overlapping with the sp3 hybrid from nitrogen. We only have 1 of those. Statement 3, they're asking us how many lone pairs of electrons are in the complete Lewis structure. So for that, you just need to make sure you fill out this thing correctly, and then we just count them up. So go 1, 2, 3, 4, 5, 6, 7. Bam, done. For our last question, they want to know how many pi bonds are in the complete Lewis structure. So if we recall back to our video lecture, a single bond contains 1 sigma bond, a double bond contains a sigma and a pi, and a triple bond contains 1 sigma and 2 pi bonds. So we're going to be looking for double or triple bonds here. We don't see any triple bonds in this structure. However, we do see 3 double bonds. Each of those double bonds contains 1 pi bond. So if we have 3 doubles, that means we have 3 pi bonds. All right, that's going to take care of question 6 for us. Stay tuned for our next video.